All right, everybody. Hello again. So, like I said in the Zoom, we need to do some fraction stuff, and I know everybody says, "Oh, I can't do fractions; they're hard," and I kind of get it. But um, so, as we do some of this stuff, I don't want to do yellow. Um, I'm going to talk about some things as if you've never done them before. So forgive me if you have a good understanding of what's going on, um, but we'll kind of get through it. So we're going to be adding and subtracting fractions today, and we have to have common denominators. Which again, a lot of you know. So a simple problem could just be 1/5 plus 3/5. And you're going to add the numerators, or the top number, and the denominator stays the same. Okay, so you could, I think a lot of times it helps with fractions to think of money. So if we thought of the fun number 5 might be like a nickel, like 5 cents. So if you had 1 nickel and then you had 3 nickels, you have 4 nickels. Like, you wouldn't change the bottom number from 5 plus 5 to 10 and say I have dimes now, but you would have 4 nickels, or you could say 4/5. Okay, so sometimes people don't always understand that concept, and so they, well, why common denominators? So again, I go back to money. So if I did 1/half plus 1/4, a lot of people that don't understand fractions, they just want to add 1 plus 1 is 2, and 2 plus 4 is 6. Excuse me. And then we do have to simplify our answer. So if I can divide, which I can here, I can divide by 2. I would say, well, I get 2 divided by 2 is 1, and 6 divided by 2 is 3, and I get 1/3. This is a wrong answer. So again, think of money. If you had 1/2 or half a dollar, you could say that is 50 cents. And 1/4 or a quarter, 25 cents. And I think you all would understand that 50 cents and 25 cents is 75 cents. This would be like 33 cents. So obviously not correct. Okay? So if we're going to do 1/2 plus 1/4, we need common denominators. And so a lot of you can probably look at that and say, hey, 2 and 4, I know what the common denominator is. And if you do, that's fantastic, and we'll go over how to change those in just a second. But there's another idea that if you didn't know, and this can be used when the numbers get bigger and maybe are a little bit harder, but if you kind of make a chart with our denominators, 2 and the 4, and times 2 times 3 times, oops, that's not what I wanted, times 4. You don't have to create the whole thing right away, but just to kind of make this chart. And so the idea is I'm going to do times 2 and times 3 and times 4 until the numbers match. So I'm going to always start with the smallest number, 2. So 2 times 2 is 4, and hey, this is kind of an easier one, but the numbers match. So my common denominator is going to be 4. So I want both of these fractions to have a 4 on the bottom. And luckily enough, I already have a matching denominator on this one, so nothing changes. But then I need to do, well, how do I get a 2 to become a 4? Well, I just did it. I did times 2. And so what you want to do is do times 2 like that. 1 times 2 is 2. 2 times 2 is 4. And then I can add the numerators. Leave the denominators the same. And 3/4 is 3/4, if you think of money. That is our 75 cents that we did on the last one. Okay, so common denominators. I think all of you remember that from middle school or whenever you first started to do fractions. But so I was able to multiply way back up here. Why was I allowed to do that? I don't think we answered that question why enough in math, and that's why some people have a hard time with math. So, excuse me. So I changed 1/2 into 2/4. How does that work? Well, what I really did was I did 1/2 and I multiplied. You see there's a 2 and a 2. And I ended up with 2/4. And this right here really equals 1. And in math, I think you all know that, 5 times 1 is 5, and 8 times 1 is 8, and 20 times 1 is 20, that whenever you multiply by 1, it doesn't change the value. So if you had, what I'm saying is the value of 1/2 and the value of 2/4 is the same. So again, money. 1/2 of $1, 50 cents. 2/4 or 2/4, 50 cents. The amount would look different. There is such thing as a 50-cent piece. They're not really that popular anymore, but they used to be. And 50 cents or 2/4, the value is still the same. If you had 2/4 and someone else had 5 dimes, you'd have 50 cents. They would look different, but the value is the same. So value is what we're concerned about. All right, let's look at a couple more. So let's do a subtraction one. 2/3 minus 3/8. So we need our common denominators. And so some of you again could look at that and you know what the common denominator is, and that's great. And you could just kind of go from there. Others of you maybe don't. And so we have like our chart again. I have a 3 and an 8. And so times 2, times 3, times 4. And you don't have to write all the way out unless you need it. But so start with the small one. 3 times 2 is 6. Okay, 6 and 8 don't match. 3 times 3 is 9. That doesn't match. And as soon as you get bigger, so 9's bigger than 8, now I need to go and do 8 times 2, 16. That doesn't match. So it got bigger. 9 or 16 got bigger than 9, so go back to the 3. 3 times 4 is 12. Times 5 is 15. Still not bigger. Times 6 is 18. Okay, it got bigger. Still nothing matches. So it got bigger, so come back down here. 8 times 3 is 24. Bigger than 18, so go back up here. Times 7 is 21. Times 8 is 24. And they match. So 24 is my common denominator. So how do I get from 3 to 24? I just did it. I did times 8 over there. So I'm going to do times 8 and times 8. So 2 times 8 is 16. And 3 times 8 is 24. I already figured that out on the other one. So how do I get the 8 to be a 24? Again, I just did it. It's right here. times 3. So I get 3 times 3 is 9, and 8 times 3, I already did it again, is 24. And then I can just subtract. Okay, so that, in my opinion, is the best way to do the problem. So some of you might have noticed that back up here, well, didn't we just do 8 times 3 and get 24? And that was the common denominator. Like, wouldn't that just be faster to do 8 times 3? And sometimes, yes, it is faster to do that. And other times, it's not. So let's look at another one. And there's a couple different things that are going to take place. So 5/6 plus 3/4. So some of you that noticed on the other one, like, well, hey, 8 times 3 is 24, and that was the denominator, so couldn't I just do 6 times 4 and say, well, I'll just do 24, happens to be 24 again, but couldn't I just do that and then say 6 times 4 and 5 times 4, so I get 20, and this is times 6 and times 6, so I get 18, and 38 over 24. So nothing's wrong with what I did, and I do need to reduce. So what number goes into both of those? Yikes. I don't know. Like, I can do a bunch in 20, but 38. Well, it's an even number, so I know for sure I could divide by 2. And then on top, that's not an easy one, but you get 19, and on the bottom you get 12. And that is an acceptable answer. So some of you might want to say, well, do I have to change it into a mixed number? Do I, need to put 12 into 19 once? There's a remainder of 7 over 12. Okay, if you do that, it's not wrong, but in algebra, that is an acceptable answer. You don't have to ever change it if you don't want to. We actually are going to do more with 19 over 12 than we are with anything else. So if you change it and you change it correctly, then that's nothing wrong with it. But if you change it and you change it wrong, then I have to mark off some points, like if it was a test or a quiz. Okay, so there's nothing wrong with just multiplying the denominators, but that's not always going to be, and this one maybe isn't super hard, but it's not going to always be the easiest thing, because you're going to have to do this like reducing stuff right here, and maybe that's not that bad for some of you, but let me show you a different way to do it where you don't have to reduce. Okay, so again, we have 5/6, 3/4. And so really the question you want to ask yourself in common denominators, so you could make the chart, but what's the smallest number that I could make a 6 and a 4 into and have it work? So again, if I did times 2, I get 8. And 8's bigger than 6, so I jump down here. 6 times 2 is 12. And nothing matches yet. And 4 times 3 is 12. So hey, here's our 12's match. So that's the lowest number. We always want to work with the smallest numbers because, well, they're easier. But so I get 12 and 12 there. And so how did I make the 6 into a 12? I did times 2. And how did I make the 4 into a 12? I did times 3, top and bottom. So remember, 2 and 2 and 3 and 3, those are just the number 1, just look different. 3 times 3 is 9. And then I get 19 over 12, which is what I got on the other one. and you don't have to reduce at the end. So if you don't mind reducing, then you could do the other way, where you just multiply the denominators together. But once those numbers just get even a little bit bigger, you could create some much more difficult problems where if you just found the smallest number, or what I think we call the least common multiple. I won't ask you that, but that's what we call it. Okay, so remember common denominators. Always reduce your answer if possible. So not all of them will be possible, but you want to reduce your answer. Okay? And improper fractions are okay. Okay, so on the assignment on Canvas, there's a worksheet. You don't need to print it out, but you can, if you want to, that's fine, and do the work. Or you can just do the work on a separate sheet of paper. And then you're going to upload it to Canvas, and then you will have turned your assignment in. And I will have already gone over that with you, but if you need help with that, please let me know, and I would be more than happy to help so that you can get stuff turned in. Okay, I will also post the answers on the school website under my name, under my school website. So it is your responsibility to check your answers. That way tomorrow, if you have questions, you know which ones you got wrong, and you can ask, and we can go over those so you can see what you did wrong. Okay? All right. Have a great afternoon/evening whenever you happen to be working on this. Please let me know if you have questions, email, and I'll try to get back to you as soon as possible. All right. Have a good one.